All right, let's jump right into this. Imagine if the phone in your pocket or the smart glasses on your face could know exactly where you're looking while you're in a moving car. And I'm not talking about using a camera. I mean, with just a single tiny motion sensor. It sounds pretty much impossible, right? But what we're looking at today is some incredible research that found a really clever way to do exactly that.
And this image, well, it gets right to the heart of the challenge. So a driver turns their head to check their blind spot. Then, a second later, the car itself makes a turn. To a regular motion sensor, both of those things, they look almost the same. It's just a jumble of movement. The sensor is totally and completely confused.
So that's the big question, isn't it? A head turn or a car turn? How can one simple sensor possibly untangle those two separate motions that are happening at the exact same time? Figuring this out is the key to unlocking a whole new level of driver safety, all with the technology that, most of us already have in our pockets.
So why does any of this really matter? Well, this isn't just some fun little engineering puzzle. Knowing where a driver is actually looking is incredibly important for preventing accidents. Is the driver getting drowsy? Are they remembering to check their mirrors before they change lanes? I mean, this kind of data can literally save lives.
Okay, so this lays out the ways we've tried to solve this so far and why they're not that great. Sure, car companies can build in expensive sensors, but that only helps people buying brand new, high-end cars. Using your phone's camera, well, that just kills your battery, it's computationally heavy, and your view can get blocked really easily. And trying to set up a bunch of different sensors is just way too complicated for the average person. We definitely need something better.
So let's get into the physics of it. What makes this so incredibly hard to figure out? It's a classic problem of, well, relative motion. And this is the perfect way to think about it. Imagine you're on a train that's just flying down the tracks. If you get up and start walking, how fast are you really going? You've got your own walking speed, sure, but you're also moving at the speed of the entire train. A sensor in your pocket is facing that exact same problem. It has to somehow separate your movement from the movement of the vehicle it's inside. Now, the little device at the center of all this is something called an inertial measurement unit, or IMU for short. It's in your phone, your smartwatch, it's basically everywhere. It uses an accelerometer to feel motion, a gyroscope for rotation, and a magnetometer, which is pretty much a digital compass. And that last one, the magnetometer, that's about to be the hero of our story. For decades, that magnetometer has had a huge problem inside cars. You've got all this metal, all these electronics, and they create a ton of magnetic interference, basically just noise. But what if that noise wasn't really noise at all? What if it was a clue? This slide shows it perfectly. See, outside the Earth's magnetic field, that blue line is nice and clean, very predictable. But once you get inside a car, all that metal and wiring twists that field into a totally unique but stable shape, a magnetic fingerprint, which you see here in orange. It's like every car creates its own little magnetic bubble. And the researchers themselves put it best. They realized they could take this magnetic noise, this thing that has always been a problem for compasses, and as they said, turn it from a foe into a friend. Instead of fighting the distortion, they decided to use it. And this is the aha moment. This is the big breakthrough. Instead of trying to filter out the car's magnetic fingerprint, they used it as a signal. That unique, distorted field moves with the car, which means it creates a stable, fixed frame of reference inside the vehicle. The whole process works in 3 surprisingly simple steps. First, the system just needs to learn the car's unique magnetic fingerprint, which it can do with a single 360-degree turn. Then, it uses that fingerprint combined with the Earth's magnetic field to figure out which way the car is pointing. And once it knows that, it can finally subtract the car's movement from the equation and see only the sensor's rotation inside. Okay, now this is the magic trick. Pay close attention. On the left, you've got a head turn. From the sensor's point of view, the car's magnetic field and the Earth's field are rotating together. This means the angle between them doesn't change. It stays constant. But now look at the right. When the car turns, its own magnetic field stays put relative to the sensor, but the Earth's magnetic field seems to rotate around it, and that means the angle changes. That changing angle is the secret signal that tells the system, hey, the car's turning, not the person.
So what does this all mean for us in the real world? This isn't just some clever lab experiment. This has the potential to make these advanced safety features available to absolutely everyone, no matter what kind of car you drive.
And the results? They are absolutely fantastic. The system can track a left-right head turn, that's called the yaw, with an average error of just over 5 degrees. And for a head nod up or down, the pitch, it's even better, with an error of less than 4 degrees. That is incredibly precise for a system that's so simple.
Now, you might be thinking, okay, a single sensor system is simple, but it must be less accurate, right? Well, take a look at this. Compared to really complex, power-hungry camera systems, this magnetic method is often more accurate, especially when it comes to tracking up and down head movements. It's simpler, it's more efficient, and in many cases, it just flat out delivers better results.
And the potential uses for this are just huge. Imagine an app that can tell when a driver is getting drowsy just from their head nodding, or one that reminds you if you start to change lanes without checking your mirror first. It could even enable gesture controls for your music or navigation. This tech could bring cutting-edge safety features to any car on the road, just by using the phone you already have.
So in the end, a problem that had bugged engineers for years, that magnetic noise, was actually hiding the solution all along. It really makes you wonder, doesn't it? What other glitches or annoyances in our world are just sitting there, waiting for someone to look at them from a different angle and turn them into a breakthrough?